Alright, so we've already looked at solving a system of equations by graphing, and generally it's not going to be very precise. There's not very many sets of equations that are going to have an exact answer that goes through a point that you can easily tell what it is. So usually it'll be like a fraction or something, and graphing just isn't really going to cut it. So we're going to look at two other methods. So the first one is going to be solving a system by substitution. And that means that we're going to solve an equation for y equals or x equals, and then we're going to plug it into the other one. We're going to substitute it into the other one. The other way is elimination, and we're literally going to eliminate a variable. We're going to cancel it out. So this way is going to be substitution. So there's a set of steps that you want to follow every single time. So first you're going to solve so that one equation is y equals or x equals. And this first day, I think they're all given to you. One of them is y equals or x equals already. So later you'll have to solve for y equals or x equals, but for now we're just going to give it to you that way. And so once you have y equals or x equals, like say you had x equals 4, you already know what x equals, so you can just go plug that into the other equation. So that's step 2. If you know what x is, because you had x equals, you can go plug that equation, whatever that equation is, whether it's just a number or if it had y's in it, whatever it has in it, you can go plug it into the other equation for x. And that'll make more sense when we do some examples here. And then once you've plugged in your equation, you'll see, but it makes it so that you've only got one variable now, not two. And so you're able to solve for that variable, x or y. And then once you figure that one out, x or y, then you're at step 4. You're going to go plug that number back into both of your original two equations to solve for the other variable. And I want you to plug it into both equations because you got to make sure that you get the same answer from both equations, because that's the whole point. We're solving for where do these lines cross, and so they need to cross at the same point. Like, you got to get the same answer because they're only crossing at one point. So when you plug in your answer, whatever you got for step 3 here, when you plug it into your original two equations, you better get the same thing, and if you didn't, that means something went wrong and you'll need to start over or find where you went wrong. So you'll get, like, say you solved for x first in step 3, then in step 4 you'll solve for y, and then step 5 you're going to write your answer as a coordinate x comma y. So let's do some examples just to make it more clear what we're talking about here. So example 1, my equations are y equals 1 and 2x minus 3y equals negative 7. So here, going through my steps, I already have a y equals. It was given to me, so I'm good to go. So step 1's done. I don't need to solve. Step 2, I'm going to plug that equation into my other equation. So I know that y is 1, so everywhere I see a y in my second equation, I'm going to put a 1. So you can see in step 2 I did that. I have a 2x minus 3 times 1 now instead of y equals negative 7. And then you're going to solve for your variable. So we know how to do this. You're just going to simplify. 3 times 1 is 3, and then you got to add 3 to both sides to cancel it out. And so I end up with 2x equals negative 4, and then you need to divide by 2 to get x by itself, and you get x equals negative 2. But I'm not done, okay? You need to know x and you need to know y. So that's where we go to step 4. So step 4, I already know that y equals 1. They gave me that. That's one of my equations. I mean, it is an equation. It's very simple, but it is an equation. So I already know y equals 1. So I don't have to plug anything back in. So that is the best case scenario. If they just give you y, you're good to go. So then you're going to write your answer as a coordinate. So I've got x is negative 2, y is 1, so I got to write it as negative 2 comma 1. So those are the simplest ones. If they just give you y or they just give you x, it's technically an equation. Like, we've graphed those before, what y equals 1 looks like and what x equals 2 looks like. But it is an equation. It's just they gave you what x or y is. It's easy. Okay, so the next one, a little bit trickier. Y equals 3x this time. And y equals 11x plus 8. So going through my steps, I already have a y equals, so that's good to go. I actually have 2 of them. So this is a special case where you have 2 that are y equals. It works the same way. I'm going to plug the first equation. I know that y is 3x. So in my second equation, I'm going to just plug 3x in for my y. So I'm going to end up with 3x equals 11x plus 8 because I replaced the y with the 3x. When you have two that are y equals like this, you're really just setting them equal to each other. I'm setting the 3x equal to the 11x plus 8. It only works if they're both y equals. And then you need to solve. So now we're in step 3. So I've got 3x equals 11x plus 8, and I need to get those x's together. So I'm going to minus the 11x from both sides. That gives me negative 8x on the one side. You just focus on the numbers. 3 minus 11 is negative 8, and I have an x hooked to it. And then I just still have this 8 over there by itself. And then from there, we just need to divide by the negative 8, and I get x equals negative 1. So now that I know x equals negative 1, now I do need to go plug it back into both my equations. So on the left here, I have the first equation, and on the right, I have the second equation. So I plugged in x equals negative 1. I've got y equals 3 times negative 1. That's just negative 3. Then go to my second equation. I've got y equals 11 times negative 1, and then add 8 to it. And so that's going to be negative 11 plus 8, which is negative 3. So that's good. They match. If they didn't match, I would need to go back to step 3 and figure out what went wrong. Maybe even step 2 and figure out what went wrong. And if I had solved in step 1, that could be a problem too. Maybe something went wrong back there. Work your way back and figure out where you went wrong. And now that I know what y is, I need to write it as a coordinate. So I know x is negative 1 and y is negative 3. So my answer is negative 1 comma negative 3. That's the only answer you can give me. It's got to be in a coordinate. Okay, next example. This one's a little more complicated. This time it's x equals. I wanted to show you one of those. So I've got x equals 4y minus 2 and 3x minus 7y equals 9. So this video doesn't go over any solving. That's in a pre-made, it's already on YouTube, so I didn't cover that. So I already have an x equals. So I'm not going to really show you step 1 at all. It's already taken care of for me here. So x equals is good to go. But I need to go to step 2 and plug that into my other equation. So I know that x equals 4y minus 2. So that means anywhere that I see an x, I'm going to replace it with 4y minus 2. So in my second equation here, 3x minus 7y equals 9, that x there, I'm going to have 3 times everything that I know is x. So it's going to be 3 times 4y minus 2. And so I need to make sure it's all in parentheses, so it's 3 times that whole entire thing, because that whole entire thing is x. So I've got that. And then in step 3, I need to solve. But this one's a little trickier. You got to distribute your 3 through. So it's 3 times 4y, which is 3 times 4, and then stick a y on the end. So that's 12y. And then 3 times negative 2, which is negative 6. So that's why I have a minus 6 there. Then the 3 is not times the 7y, so it's just minus 7y. The 3 is only times the stuff in the parentheses, and then equals 9. And then all I did in this next line here, this third line down, I just rearranged stuff. I have 12y minus 7y now, and then minus 6, because I wanted to put the y's together just so you could see when I simplified a little bit. So it's okay to rearrange those things as long as you bring the negatives with them. So it was a negative 7y, so I had to make it a negative 7y when I moved it. And then this negative 6 was a negative 6, so I needed to make sure it was still negative when I moved it, if I'm just switching it around like that on the same side. So then I end up with 12y minus 7y, and that's just 5y. That's how I got that there. And I still have minus 6, and I still have the 9 on the other side. And then I have to add 6 to both sides to get y by itself. And so I end up with 5y equals 15, and then I need to divide. So I end up with y equals 3. So now that I know that y equals 3, I need to plug that back into both of my equations. So I've got x equals 4 times 3 now, minus 2, and that simplifies to 12 minus 2, and then 10. Then in the other one, it's got a little bit more solving involved. 3x minus 7 times 3 now, because y is 3, equals 9. Then I simplify. I know that 7 times 3 is 21, so I replace that. And then now I got to solve for x. So I'm going to add 21 to both sides. I end up with 3x equals 30, and then I got to divide by 3. And then I get x equals 10. So I know that y equaled 3 from step 3 up here, and I know x equals 10 from step 4, so I'm going to write my answer as 10, 3. And make sure you get the x part first, because here it was backwards. I solved for y and then I solved for x, but you got to make sure you write your coordinate as x, y, because that's how coordinates are always written. X always goes first, whether you solved for it first or not. So that is all the examples I want to go over. There will be another video on Moodle about how to solve the equation first and then plug it in. But otherwise, all the steps are the exact same except step 1. They're going to just show you a little bit of solving.